This is Sung, and I'm the Principal and Director of Sky Academy. And in the last episode, what we did was we looked at volumes of solids of revolution. And I gave you the theory on basically what it is. It's when you take a curve and you rotate that curve around the x-axis, and you are looking at the volume that's created by doing that, by rotating the curve around the x-axis. All right? And we came up with a specific formula that that resembled the formula for finding the volume of a disc or a cylinder. Do you remember that? Okay. Now, the formula that we came up with, all right, this is basically the formula in a nutshell. The volume is equal to pi times the integral from a to b of the square of the function dx. Okay? So, I'll show you how to do specific examples like this, but this is basically the formula for the volume of a solid of revolution made by rotating that function about the x-axis between x is equal to a and x is equal to b. Alright? Good. So let's have a look at a specific example. Alright? If we launch into a specific example, it might make things a little bit clearer. Alright? So here we go. Find the volume of a solid of revolution formed when y is equal to x cubed, and so we've got the formula for the function, the graph for y is equal to x cubed, is rotated about the x-axis between 0 and 2. Okay? So do you see I've actually done the work in advance, and so what we want is the function between 0 and 2, 0 here and 2 here, rotated around the x-axis, and it's going to look like the bell of a trumpet. Okay, do you see that? And what we're going to do is we're going to find the volume of that using this formula. Okay, so the volume is going to be pi times the integral from 0 to 2 of x cubed all squared, because we're squaring the function, all right, and then that dx, all right. So that is what we're trying to find. Let's work that out. That gives us pi times the integral from 0 to 2. X cubed squared is x to the power of 6 dx, right? Which gives us pi lots of x to the power of 7 on 7 when we integrate it. So when we integrate x to the power of 6, we get x to the power of 7 on 7, alright, between 2 and 0. Does that make sense? That's going to give us pi lots of 2 to the power of 7 over 7 minus 0 to the power of 7 over 7, which gives us, what's 2 to the power of 7? Alright, so let's work this out. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 8 times 16, 64, double 64, 128. So basically, the volume is going to be 128 pi on 7 units, cubic units. Does that make sense? Do you understand, or do you follow what we've just done here? All right? This is basically the way that we find the volume of the volume of a solid of revolution. Okay? Good. All right. Let's have a look at this example, because this example is slightly different. What this example takes into consideration is that we are now rotating the function about the y-axis, not the x-axis. Okay? So what we're doing is we're considering rotations about the y-axis. So let's read it out. Find the volume when x y equals to x squared is rotated about the y-axis between y is equal to 1 and y is equal to 4. Okay, so to do this sort of question, the first thing we have to do, remember when we're rotating about the y-axis, is make the function change the subject of the formula. So we need to make the function expressed in terms of x as opposed to in terms of y. So let's do that first, and I'll do this over here. So y equals to x squared becomes x squared equals to y, x equals to the square root of y, all right? And is it positive or negative? Well, we're rotating this arm about the y-axis, so let's make that positive, even though there will be both the positive arm and the negative arm, okay? But we're rotating the positive arm around the y-axis, so let's use the positive, okay? And in fact, I will probably label it like this, y to the power of a half, okay? Good. So let's work this out. So the volume of revolution is equal to pi times the integral, and in this case it's the integral from 1 to 4. See, the limits have already been given to us in terms of y. Alright, so if the limits were given to us in terms of x instead, we would have to convert it to the y, okay? To limits in terms of y. Alright, so here we go. Pi times the integral from 1 to 4 of the function, which is y to the power of a half, y to the power of a half, all squared. And this time, because we're rotating around the y-axis, we're integrating with respect to y. Okay? So all of that would equal pi 1, 4, y to the power of a half to the power of 2 is just y to the power of 1 dy, which gives you pi times y squared on 2, 4, 1. Okay, let's work that out. Pi 4 squared on 2 minus 1 squared on 2 gives you pi 16 on 2 minus 1 on 2 gives you 15 pi on 2 cube units. Does that make sense? So hopefully you can follow the algebra, but the key to notice with these sort of questions when you're doing volumes of solids of revolution is that you need to square the function, alright? Just like we squared the function there and we squared the function there, alright? And when you're doing volumes of solids of revolution rotating around the y-axis, the other thing to remember is you need to express that function making x the subject of the formula in terms of y, like we did here, and also change the limits and integrate with respect to y as well. Good. So I hope you enjoy doing questions involving volumes of revolution. I enjoy doing them because it's because I get to draw all these weird and wonderful shapes, all right, that look really complicated and fancy, but really it's not that complicated. Okay, so enjoy doing them. Thank you very much for watching.